All right, here we go. Review for the Chapter 5 test. So let's go through here. Again, like I said, you can kind of tell me what you want to skip over, what you want to concentrate on. You okay with changing that? Okay, I'll tell you right now. I'm not putting that on the test. It's going to be taking it from minutes and seconds, but I'm not going to give you a single problem where it says just change this to the nearest whatever thousandth in this case. It's going to be like part of. It's like the quiz you just got back. Wasn't there a couple on there, like number 4, 5, and 6? Do you see where it says angle A is 37 degrees, 20 minutes? So you got to convert it. So it's not just going to be just a question where it says convert it. It's going to be part of one of the other ones, okay? So if you want to do that, we can. I think I do put that on there. That's easy. How do you do that? Yeah, that's all you do. Okay, because one time around, one rotation is 360, 2 times around is 360 times 2. So that means 2.6 rotations would be 2.6 times 360. Yeah. Okay. Yeah, counterclockwise is positive, and then clockwise would be negative, correct. Okay. I put one of these on here. I got the test already made up. I just have to, I just copied all the stuff from the quiz and put it on there, picked out which ones I want to put on there, but tonight I have to go through and like change the numbers around a little bit, okay? But I do have it already made. So anyway, one positive, one negative. Seems like we just did that. Did we have that recently? I don't know. How do you do a positive that's coterminal with that angle? Just add a 360 to it. So it's 43. Oh, we did this in my Algebra 2 class. That's why I have that in my head. They did that in the Algebra 2 test. And then a negative, so you're going to get 2 answers for this. All right, again, I'm not going to put the numbers in just because of time. All right, but one positive, just 43 plus 360. A negative angle that's coterminal, 43 minus 360. Good. And whatever that comes out to be. All right, state the quadrant. I don't think I put that. I don't think I put that. I'm not 100% sure. I can't remember. But what would you do? First of all, you got to figure out what quadrant it's in. So 472. So what would I do? 472 means it goes around more than once, right? So if I wanted to figure out where it goes around just one time, what would I do to that? I would subtract a 360, right? And so that's a 2, that's a 1, and that's a 1. So where's 112 degrees? So this would be 112 degrees, because it says it is, and okay, determine a coterminal angle. That's your coterminal angle, and state the quadrant where it lies. So where is it? It's in here somewhere, isn't it? So what quadrant's that? That's the second quadrant. That's what there is to that. All right. I can't remember, but it's easy to do. All right. Figured we went over it just in case I forgot. All right. So this one right here, sine, cosine, and tangent for angle B. What would you have to do first, though? You're going to have to find this missing side, correct? All right, so how would you find that missing side? Pythagorean theorem. So it eventually boils down to what? The square root of 8 squared minus 3 squared, isn't it? All right? Yeah. Yeah, 8's the c. Because it's a squared. I'm just trying to streamline it, just trying to make it a little quicker and easier than writing out the whole thing from the beginning. All right, you've done Pythagorean theorem enough to know if you're trying to find one of the legs, you just take the hypotenuse squared minus one of the legs squared, take the square root, and again, you can put the number, I don't know, what is it, square root of 55? Okay, and now you got to find the sine, cosine, and tangent. I'm not even going to write them down. Let's just talk through it. The sine is the what? Opposite over hypotenuse, so it's 3 over 8. Everybody good? All right, and then the cosine of angle B would be what? Adjacent over hypotenuse, so it would be square root of 55 over 8. You don't have to simplify that, just keep it like that. And then the tangent is what? The opposite over the adjacent. I will write this one down. So the tangent is 3 over the square root of 55. You don't want to leave it like this because it's not simplified. All right, now they don't say to simplify, but you should always simplify. All right. What do we do here? Square root of 55 on top and bottom. And so you get 3 square root of 55 over what? Just plain old 55. So that would be the tangent of angle A. But you're going to list them all, right? You're going to put sine of angle B, cosine of angle B, tangent of angle B, and you just give me the ratios. You don't actually have to find angle B. You just give me the ratios. We good? Let's keep going. Number 7. If the sine is 3/8, or if the sine of theta is 3/8, so what I got to do is I got to set something up. The sine's going to be positive. Well, let's. I don't even have to do that. This is way easier than I thought. I'm thinking ahead to something else. This is way easier. If the sine is 3/8, the cosecant is the what of the sine? It's the inverse of the sine. Remember, it's the sine and cosecant that are inverses of each other. Some kids in my Algebra 2 class were telling me that the cosine and cosecant are inverses of each other. Why? Because they thought, well, they start with the same letter. But no, they're inverses, so they start with the opposite letter, okay? So the cosecant is the inverse of the sine. So all you do is do what? Just flip it. Boom. That's easy. All right? What about this one? Sine of negative 90. Where's negative 90? That would be right here. What's the ordered pair to that point right there? 0, negative 1. Right? So this is what I meant by we are kind of doing the unit circle, right? So that's 0, negative 1. What's the sine? Is it the first one or the second one? It's the second one. That's all you got to know. So the sine of this is negative 1. The cosine would be 0. The tangent would be negative 1 over 0, which is undefined. They just asked for the sine. All right? What is the cosine of 135? Well, draw a little thing. Cosine of 135. Now, you must get, doesn't say here, but I'm telling you right now, you must give exact answers. Okay, so don't just put the cosine of 135 in the calculator and give me a decimal answer. That's not good enough. I want exact answers. Everybody understand that? So where is 135? Well, if you go up here, that's 90. How much more do you have to go? 45. So that's a 45. There's the triangle. So that's a 45-degree angle. Remember, if we memorize these numbers, remember the hypotenuse is 1. What's this side right here? That's the square root of 2 over 2, correct? What's this side right here? It's the square root of 2 over 2. If it's a 45, 45, 90. But this is going to the left, so what kind of, it's a negative, right? So what are we talking when we talk about the cosine? We're talking about the x value, right? So what's the cosine of this angle or this angle right here? It's negative square root of 2 over 2. All right, this is what I was thinking we were going to do for this. All right, so here's what we're going to do. It says find the value. Let's push this over a little bit. All right. So let's put this point in here. Negative 3, negative 4. 1, 2, 3. 1, 2, 3, 4. It's going to go about right here. Agreed? What we're going to do, oops, let's use a straight line. Let's pop this up to there, and then we're going to drop that down to there. So we're going to make a little triangle out of it. Now this time it's not necessarily a unit circle. That hypotenuse is not necessarily 1 right now, because what is this? This is negative 3. This is negative 4. Okay, you with me? Here's our angle that we're trying to find. So let's find the value of the 6 trig functions for angle theta in standard position if the point lies on the terminal side right there, negative 3, negative 4. And so now we have to find the 6 trig functions. What are they? That's the sine of theta, the cosine of theta, the tangent of theta, and then its inverses, correct? What's the inverse of the sine? We just said it. Cosecant And then the inverse of the cosine is the secant. And the inverse of the tangent, that's always an easy one. Oops, except I can't write it. Cotangent. All right. So the sine is the opposite over the hypotenuse. Problem is we don't know the hypotenuse. The good thing is we can find it super, super quick. What is it? 3, 4, what? How about 5? 3, 4, 5. Don't want you doing any square root stuff. This is a Pythagorean triple. You should know 3, 4, 5 triangle. Don't waste your time putting it into the Pythagorean theorem to find this. Now you could, and you could still get a 5 out of it, but it's going to take you longer. Okay, why bother doing that when you see it? 3, 4, 5. Now, I don't know. I'll tell you right now, I don't know if on the test I'm going to make it a Pythagorean triple or not. It's just 5. Okay, because if I square this, if I square negative 3, it's a positive. If I square negative 4, it's positive 16. Okay, so it's going to be a 5. This hypotenuse will always be positive, all right, when you do these kind of problems. All right, so now let's just do these. What's the sign? Opposite over hypotenuse, so it's negative 4 over 5. The cosine's adjacent over hypotenuse. That's negative 3 over 5. Everybody see that? Negative 3 is adjacent to that angle. The tangent is the opposite over the adjacent, so it's the opposite over the adjacent. So that's negative over negative, which is what? Positive 4 over 3. Once you get those, you could just go straight from here to here, couldn't you? That's what I would do. Why? Because the cosecant's the inverse of the sine. So what's this going to be right here? Without even looking at this and figuring out which one's adjacent, hypotenuse, opposite, and all that, what's this going to be? Negative 5/4. You keep the sign the same, all right, but you just flip the fraction. Super easy. Secant's the inverse of the cosine, so that's a negative 5 over 3. And then the cotangent's the inverse of the tangent. It's still positive, so it's 3 over 4. There's your 6 right there. Good? All right, let's keep going. Switch quizzes. 15 minutes. Do you want to go over any from that quiz I just gave back to you? So you just want to concentrate on this one? Okay. I don't know if I'm going to do every single one of these. Let's do either 1 or 2, and then either 3 or 4. I think that's what I do on the test. I give you either something like 1 or 2 for one problem, and something like 3 and 4 with the minutes and stuff on there. Okay, so 2 and 4. All right. All right, so A is 17.3. Angle B is 77 degrees. And find C. So we're looking for that. And that's all we got to find. We don't have to find everything. We just got to find that. All right, so let's use this angle right here. They give us the adjacent side to that angle, and you want to find the hypotenuse. So which trig function are we going to use? Adjacent hypotenuse. Which one? Cosine. That's right, because cosine is the adjacent over the hypotenuse. All right, so I do the cosine. The cosine of what? You always take the cosine of the angle. All right, so what angle are we using right here? 77 is equal to the adjacent over the hypotenuse. So it's 17.3 over the hypotenuse, which is C. We've got to do a little math. You should be able to do this in your head at this point. Look where C is. It's on the bottom, isn't it? We don't want it on the bottom. Where do we want it? On the top. So I'm going to take it, I'm going to multiply both sides by C, put it over here, and then I got to get rid of that cosine of 77. We're not taking the inverse of it, all right, because the cosine of 77 is just a number. So I divide it. That's right. So we could do that in our head, can't we? So C goes up here, cosine of 77 goes under here, so it's 17.3 over the cosine of 77 degrees. And that was what, number 2? 76.9 is what I got. Okay? That's all there is to it. Make sure you know how to put that in your calculator. Have you a little confused? What's your question? How did I go from here to here?
No. You took the cosine of 77.
Right, the cosine is the adjacent over the hypotenuse. Okay, this is adjacent. If I wanted to solve for B, what would I use? The opposite, that's right. Okay. Now I can't use, well, Yeah, opposite over adjacent, which is the tangent. Everybody see that? Okay. All right. Let's get rid of those. Okay. Let's look at 4. First thing I'm going to do is I'm going to change that minutes thing. Okay, I don't like that. So I'm going to go 16 plus 55, what? Over 60. Okay, so that's what I'm using instead of, it's not 16.55, is it? All right, so it's 16 plus 55 over 60. That's not my answer. I shouldn't have circled it, but you get the idea. Let's not circle it. Let's put it in a box. All right, so that's what I'm going to use for angle A. Everybody see that? So this is going to be, I probably would not, let's just use, I'll tell you, this is how I'll just show you how I did it, okay? So, I don't know if it makes more sense for you, maybe another thinking of it a little bit different. I would not put that into a calculator and round it, okay? Because you're not gonna get an accurate answer. I would keep it this when you put it into the calculator, all right? So what's gonna go into the calculator? Remember, this was 16 degrees. I'm gonna write this as 55 minutes, okay? But when it's ready to put in the calculator, then I'm gonna put it in like that. Everybody okay with that? All right. What else they tell you? C is 13.7, so they tell you the hypotenuse, and they want you to find A. Let's figure out what trig function we're gonna use first. So we're using this angle. Yeah, this is opposite. This is hypotenuse. We're using the sine. So we're gonna go the sine of 16 plus 55 over 60, okay? Everybody got that? Okay, is equal to opposite over hypotenuse, opposite, which is A, hypotenuse is 13.7. The math on this is a little bit easier. So how do you get A by itself? Multiply it by 13.7. And this right there is what I would put into the calculator. I would not put the 55 over 60 in there unless, like if it was 30 over 60, that's a half, it's 0.5. Yeah, you could just put 0.5, okay? That's not that hard. But if it comes out to a weird number, and I don't know if that actually stops or if it keeps going, whatever that number is, I would use the whole number in the calculator, all right? So you put that in the calculator, number 4, this actually comes out to 4.0. So it does round, all right? There are some other decimals afterwards, but it does round to 4.0. All right, don't just put 4 because this says round to the what? To the nearest tenth. All right, so you must have a decimal place here in the 10th value. Now look, I've been really nice for actually all my classes. I shouldn't do this, but I am. Some of you guys are not rounding correctly, and sometimes I'm getting people putting 2 digits after this. That's not the nearest tenth, is it? Other teachers would mark that wrong. I'm just letting you know right now, okay? Other teachers, not everybody, but some teachers would mark it wrong if you put 4.03 or something like that. Like, that's not rounded to the nearest tenth. Wrong, okay? I'm a little bit lenient on that.
You would do, for like spring that 102, would you use 77 instead of 76.9? Is that all right?
No, because it's not to the nearest tenth, all right? You look to this number right here. See that one? That one either rounds that up. If it was an 8, right, it might have rounded it up, or it might stay the same if that was a 3 or something like that, right? So you must have a decimal place right here. Don't make that 77.0. I still will probably be lenient on the test, but I shouldn't be. All right, here we go. What about this stuff? Oh, 6. Oh, okay. You gonna do that one? So here's what I'm gonna do. Let me see. Yeah, so I am gonna draw one of these, X and Y axis, and I wanna find out where the sine, just put it up there. Where is the sine, the negative square root of 2 over 2? Well, sine is the Y value, isn't it? So the y goes what? It goes up or it goes down. Which way is this going to go? It's going to go down because of that negative. So, and it's the square root of 2 over 2. Do you have an idea where the square root of 2 over 2 is if it's the sine? It's a 45-degree angle, isn't it? All right, so again, you should recognize that. Now, it goes down in this quadrant, and the sine goes down in that quadrant. It's not going to be in the first and second. Why not? Because the sine goes up. The sine would be positive, correct? So where's the sine negative? The sine is negative in the third and fourth quadrant. So it's going to be both of these angles, all right? And so what is this angle? Well, this is 45. So this is what? 180 plus 45 gives you 225, correct? And this is also a 45 degree. Just put it right there. And again, it goes down. Where is this? Well, if you go all the way around to 360, back it up 45, take 45 away from it, and that gives you 315. So that's how you get those two answers. Does that make sense? All right. Let's pick another one because we're running out of time. We've got like 7 minutes. So if you have a preference, let's do 9, and then if we have time, we'll do 10, okay? Did we do this? Oh, that one's super easy. On this one, do you know how to do this? You okay with that? Watch, we're going to do this, right? It's positive and positive, right? So what is the cosine? Cosine is what? Adjacent over hypotenuse, correct? So it's going to be up in this quadrant somewhere, correct? Because they're both positive. That doesn't happen here, here, or here, right? So, and you got to be in the first quadrant anyway. Sorry. All right. It says in the first quadrant. So if this is the angle, that's the angle. This is adjacent. This is hypotenuse. So the hypotenuse is going to go here. Where's the adjacent go? Down here like this. Again, this is a Pythagorean triple. All right. You recognize it? 5 blank 13. Anybody remember? 5, 12, 13. That's right. So we've set it up. Okay. This right here helped us set this up. Make sense? Now we just take the tangent of this. So what's the tangent? It's opposite over adjacent, 12 over 5. That's your answer. Make sense? Okay. Again, if you need me to go over some of these other ones, go back to the video that reviewed for these particular quizzes. I think I have a review on every one of these quizzes. All right, so go back and watch it. All right, which one do you want to do, 9 or 10? You pick it. 10's harder? Okay. So here's our triangle right there. So angle A is 35 degrees. Put it right there. And then side B is 8. So that's 8. And we got to find everything else. All right? Well, angle B is super easy. How do you do that? 90 minus 35, which is 55. That's not the problem. A and C are the problems, right? So let's do A first. Put it right there. So they give me B, and you want to find A, at least on this one right here. So what do I got? I got opposite, and I got what? Adjacent. So which trig function are we going to use? Tangent. So we go to the tangent of 35 is equal to opposite, which is A, over the adjacent, which is 8. This is the easy math. Just multiply both sides by 8, plug that in your calculator, and you get about 5.6. And it does say round to the nearest tenth. Again. All right, C, let's do trig function again. Now, some of you guys might want, you're probably thinking, oh, I got 5.6, so why not just do Pythagorean theorem? Again, your answer might be off slightly. It'd be very close, okay, but it might be slightly off because you're using an approximation right here. It's not exactly 5.6, is it? All right, I put equals, but technically I should have put a squiggly equals, all right, to get 5.6. So let's do trig again with the same numbers they gave us to find C. So I want to find C this time. So this time, this is what? This is the hypotenuse, and this is the adjacent. So what uses adjacent and hypotenuse? That's the cosine. So we take the cosine of 35 degrees It's what are we doing? What did I say? Cosine. Adjacent over hypotenuse, right. Adjacent, which is 8, over the hypotenuse, which is c. We did this math once earlier. Can you do this in your head at this point? I think so. Yeah, it's just 8 divided by cosine of 35, correct. See how easy that is once you get the hang of it? Yeah, you stick that in your calculator and you get 9.8. Easy peasy, yeah. All right, this is the quiz I gave back to you,
Or that you just took.
or you just took.
Can we go over 10?
Number 10, okay.
It's easy. I can explain it. That's the only one. You want me to explain it for me?
Let me get it out so I can see it.
Oh, so I didn't do it. Wait, that's what you had?
So look, these are areas. It looks like the same problem, doesn't it? This and this, but they're not.
Yeah.
So on this one, you use that Heron's formula, right?
The 1/2 BC side of it.
The square root. No,
Oh,
it's 1/2. The square root of s times s minus a, s minus b, s minus c. That's Heron's thing. But on this one's different because you're finding, you're solving for each missing part. So really, they give you 3 sides, so you're finding all 3 angles is what you're doing.
All
right.
Is the law of cosine.
Yeah, so you're going to use law of cosines on this.
Cosine.
This doesn't necessarily have to be very, I don't know what you call it. I said that word a bunch in my other class anyway. So we'll call this 5, we'll call this 6, we'll call this 7. Is this necessarily a right triangle? No, it's not, okay? And it's definitely not a right triangle. There are ways to figure out if it is or not. We're not going to do that because we're running out of time. So what can you do? If this is 5, then this is A, right? If this is 6, this is B. If this is 7, then this is angle C. Let's do A first. All right, I don't care. Let's do C. Is that all right? No, let's do the one that I did. I did A. Yeah, I did A first. So let's do A. Let's find that. Here we go. So law of cosines. So we're going to use the side that's opposite. We're going to square it. So 5 squared equals the other 2 sides. 6 squared plus 7 squared minus 2 times 6 times 7 again times the cosine of the angle that's opposite the 5, which is A. All right, again, because of time, subtract 6 squared, subtract 7 squared, take that, divide it by -2 times 6 times 7. Everybody see that? Let's write it out. Might as well. You got a minute, right? If the bell rings, to at least finish this up. -2 times 6 times 7. Now, we got rid of that. We got rid of that. That's all. This is all equal to the cosine, right? But what if I want to find A? A is the what? It's not negative cosine. It's the inverse cosine. You got to practice using your calculator on these, okay? I can't stress that enough. So make sure you go back and you do this. So you get 44.4 degrees. All right, that's this angle right there. Now, you could, if you wanted to, solve for angle B or solve for angle C using law of cosines again. That would be perfectly fine. You could do that if you like the law of cosines. Or let's switch it up a little bit. What if we wanted to use the law of sines? That's 44.4 degrees. Nobody wants to stick around? So what are you trying to do? Trying to find an angle, right?
Oh, I did do that.
Which one do you want to find? Let's find angle B. All right, so since I'm finding an angle, I'm going to do this. I'm going to go the sine of B over little b. What's little b? 6 equals. Now I got to know the angle on the sides. All right, so I'm going to go the sine of 44.4 over 5. Do the math. How do you do the math? Multiply both sides by 6, correct? And then b is the what? It's the inverse sine of all of this stuff. And then you'll get 57.1. So angle B is 57.1. That's the only hard stuff you had to do. Then you just add those up, take them away from 180, and you get C, and I got 78.5.
I just, what I did was, cosine of A equal, like the formula of cosine of A equals, it was B squared plus C squared minus A squared over 2BC. And it came out to the same thing.
Okay.
I think that's what they gave me in the book for.
You
just
could, I mean,
straight cosine of A.
you could use the cosine for both of those, all right? But you should get the same answer.
Yeah, I think that's right.
Now, this might be slightly off because you're using an approximation.
What am I using?
because 44.4 isn't exactly, because we rounded it to get
Oh,
44.4, okay? But if you use the law of cosines again, I didn't do it both ways, but you'll get really, really close.
I use the law of
Close
cos-
enough where I'm not going to mark off
I used
for
the
it.
law of cosine both times.
Yeah, that's fine. That's perfectly fine.
What is the quiz just for 5?
It's a test.
5, 8?
It's a test. It's over all the stuff on these quizzes. So it's a full chapter, but we skipped a little bit. Let's see.
I know we skipped 5, 7.
Okay, so the first one's 5-1. I don't know if 5-2 is a part of that or not. I can't remember. Because I think,
There's no 5, 7.
I don't know. Yeah, so anyway, it's just everything on these quizzes. So just anything that's on these quizzes right here, that's what's on the test. Okay? But again, what I would suggest is you go back and watch the videos of the reviews that I did for those particular quizzes. All right, because I don't give you the exact problems, but of course these aren't going to be the exact problems on the test anyway. Okay, they'll be close, but it'll be just like it. Right, it'll ask for the same thing, except instead of 146.2, it might be 153.7 or something like that. Okay? All right?